As a computer professional, you'll often be asked to configure a computer or find a particular model of a PC that works very well for a family member, for a business associate, or for other folks. And you might want to determine first what someone wants to be able to do with this computer. Depending on whether they are doing graphics work or whether they just want to surf the net, may determine the type of components and the type of systems that you'll recommend for each individual exercise. In a business environment, especially one dealing with highly technical documents or engineering, you may run into requirements for configuring CAD or CAM systems. These stand for Computer-Aided Design and Computer-Aided Manufacturing. These require a lot of detail. There's architectural work. There's very detailed engineering designs that go into these. And because of that, you need to make sure that the system that you recommend is going to have a very, very high-powered processor. It's going to be doing a lot of calculations. There's usually 3D type work and modeling that is done. So you want to be sure that the main CPU of this computer can handle the load that will be asked of it. This is also, as you can see, a very graphically intense environment. You can have a lot of different things on the screen, and you need to look at, in some cases, in a three-dimensional form, and that's really going to need a lot of resources on your video card. So you want to be sure that you have perhaps a specialized video card, one with plenty of video memory, one that has a very high-powered GPU on it for the graphics processing unit so that it can keep up and do everything that it needs to do visually on the screen and do it very, very quickly for the people using these applications. And almost certainly these applications are going to use a lot of memory. So you want to be sure that the operating system you select and the motherboard or PC that you select is one that will be able to use as much memory as possible. The first is to make sure that the audio input and the video input that I have into this system are as powerful as possible. I'm dealing with very high-end video and high-end audio, and ultimately I'm editing that down for a format that works well on the web, a format that works well on a DVD, and usually I'm working with high-definition video. So I want to be sure that the audio sounds as good as it could possibly sound, and the video looks as good as it possibly can at the resolutions that I happen to need. You'll also find when working with audio systems and video systems, especially video rendering, that there is a lot of input and output to the hard drive. There are a lot of different temporary files written and a lot of information that needs to be written and read all the time while you're editing these systems. So you want to have a very big hard drive. It needs to be very fast. And if you can afford to use SSDs, especially use SSDs for your temporary files and your operating system files, you'll find that you'll get very, very good response times in your audio editors and your video editors. And I'm using dual monitors on my computer because I can do a lot of different things at one time. I can edit on one screen and then I can view the results of that edit on another screen. So make sure that you take advantage of multiple monitors and that you have an adapter card for your video inside of your computer that can support multiple monitors at one time. When I'm creating these training courses, I'll often be running multiple operating systems on a single desktop. I'll run my Mac OS X operating system on the base of my computer. I might have a Linux machine that is running in one window. I might have a Windows Server in another, and maybe even Windows 7. Well, that's 4 different operating systems all running at the same time on the same physical computer. One of the primary resources that are used when you have all of those operating systems running is the amount of memory in your computer. Every operating system is going to be using a large amount of memory. So make sure that if you're planning to do a lot of virtualization, that you've loaded up the amount of RAM inside of your computer to handle exactly what you need. The CPUs we use today are specifically designed to handle this type of virtualization all in hardware. And if we have a CPU with multiple cores, then it's able to do more calculations at the same time than perhaps a CPU with just a single core inside of it. So if you're planning to have a lot of different virtual systems running on your desktop, check your CPU, make sure that it's designed to do this virtualization in hardware, and then make sure that you've got plenty of power and plenty of CPU cores to be able to run these virtualized environments as efficiently as possible. It's interesting that of all the things that you could use your computer for, it seems that gaming is the type of application that makes the most use of all the hardware and all the software inside of your computer. If you're planning to put together a gaming PC, it needs to have the biggest and baddest processor that you can find because it's going to be doing a lot of calculations to be able to provide this entertainment to you. You'll also find that the latest games have very, very advanced graphics in them. It seems that these gaming systems are what's really driving a lot of the graphics capabilities these days, and it may be that you require a separate video card. Sometimes your video card can cost as much as the rest of your computer just so that you can have the best possible gaming experience on that system. A sound card will make all the difference in games today. As you have better sound cards, you can have much more crisp and clear audio along with multiple tracks of audio that can run at the same time. If you have a sound card that it cannot provide the same capabilities, then you're not going to have the same gaming experience. And because the CPU and the GPU and the memory and all of the processors of your computer are running all the time, your computer is going to get very, very warm very, very quickly. So you want to be sure that you have a very efficient cooling system to make sure that the inside of your computer stays as cool as possible. Our computers are now starting to arrive into our living room, and you'll see a lot of home theater computers that are integrated into very specific types of hardware so that we can provide that type of rich media experience on our television in our home. In environments like this, you want to be sure that these systems can handle surround sound audio. For our home theaters, we're not just using a left and right channel. We have a center channel. We have a subwoofer. We have surround sound speakers to the side and behind us. So we need to make sure that the hardware inside of our media center PC is compatible with that type of audio input and audio output. These systems are usually also designed to provide high definition video. So HDMI output is very, very common so that we can easily plug into the commercial televisions that you can get right off the shelf. These are also very small. We don't have a lot of room inside of our home theaters. Usually we've got a shelf and we can fit a specific kind of system, not really designed for big computer towers. So very often it will be this home theater PC compact system so that you can fit it very, very simply into your living room. And of course, if you want to watch regular television, this device will also need a way to tune into those television signals, whether it's over the air or it's a signal provided to you by your cable company. When we think of a traditional computer, it's usually a thick client that we're referring to. It's a big operating system that is loaded on a hard drive. It launches Windows 7. It launches your Linux operating system or your Mac OS X operating system. All of the processing happens on that computer. So you want to make sure that you know what desktop applications somebody's going to run. They may be running a slideshow program. They may be doing word processing. They may be using spreadsheets. All of those applications are running on that local computer, so you have to keep in mind the type of CPU resources you might need for that. And also you might want to check how much memory those applications are going to use and how much disk space those applications are going to use so that you're able to spec out a system that fits exactly those requirements. In a lot of environments these days, we're seeing companies move away from the thick client and move to a thin client. The thin client, as the name implies, is a system that doesn't have a lot of local resources. It may be just a very small box that connects up your monitor, it connects up your keyboard, it connects up your mouse, but it doesn't do a lot of local processing. The applications are usually run on a completely separate server, and that's where you're going to be investing all of your heavy resources is on that server. Sometimes you'll see this referred to as VDI. That stands for a virtual desktop environment. Your desktop isn't really running on this computer. This device is really designed to show you what's happening on that remote server that's located somewhere else in your organization. So it doesn't need a lot of horsepower. It doesn't need a lot of graphics capabilities. You don't need a lot of memory or a lot of disk space. It needs just enough resources to be able to get that thin client up and running. And from that point on, all of the heavy processing is done on the remote server. If you have a high-tech household, then you probably have the need for a home server PC. One of the things that these home server PCs do is provide things like media streaming. We can put all of our video content on one computer, and it can stream that content to all of the video devices inside of our home. We might also want to centralize our file sharing here as well. Maybe we take all of the documents that we own, we scan them in. They're now all stored right here on this centralized server. If you have printers that you need to be able to access from anybody's computer, maybe we just plug the printer into our centralized home server, and we simply all will use this networked printer just as if you were at work using a networked printer there. These are usually home servers that have very high speed networking in them. You've set up a gigabit network because you're running video and audio and other documents and file transfers all at the same time. And because we're doing all of this on this home server, obviously the data that we're storing on this is extremely important. So it's becoming very common to see these home servers have multiple hard drive arrays, and then we can store all of that data on a RAID protected array. If we were to lose any of these hard drives, we would get a message that a hard drive failed, but all of the data would still be intact. We can simply swap out that drive and maintain the redundancy on these home media servers.